Today we are going to discuss ring modulator. This is another type of modulation which is going to generate double sideband with suppressed carrier. So this type of modulation use four diodes and a center tapped transformer. So you can see the circuit diagram of a ring modulator is that the input message signal is going to be inputted from the transformer, and then it goes to enter, and then you can see there are four diodes, D1 and D2, they are on the forward direction, and the D3 and D are on the backward direction. And you can see that the carrier is connected to the center tapped transformer. And then after that you are taking the inputs from that transformer, and that input is being inputted to the band pass filter, whose center or cutoff frequency is FC and whose bandwidth is 2 FM. And then you will take the output VOT from the band pass filter. So let's talk about the working of the ring modulator. Start with the first half cycle, the positive half cycle. Positive half cycle. The second point, you need to take in consideration that the diodes are always work based on the amplitude of the carrier signal, because we know that the amplitude of the carrier signal is always dominating the modulating signal. So like the amplitude of the carrier signal is always much bigger than the amplitude of the modulating signal. So these diodes work on the basis on the amplitude of the carrier signal. So first consider the positive half cycle. So if you are considering the positive half cycle, so it means that the positive here, negative here, positive here, and negative here. So it means that, so this is positive, this is negative, and this is positive, this is negative. So this is, if this is positive, so it means that the P type is positive, so this is P type, and this is N. So P is positive, so then this is short circuited. So here also P positive, so this is a short circuited. So this is N type is positive, so this is open circuited. N type is positive, this is open circuited. So it means that D1 and D2, so they are short circuit or closed switch, and D3 and D4, they are open circuited or open switch. And then whatever the message signal, so that will go through this way and then go through that way, and then you will end up with the positive cycle of the message signal. VIT is the positive of the message signal. Center is the second is the negative half cycle. So if negative half cycle, so it means that you will having negative here, so negative here, positive here, negative here, positive here. So it means that you are having negative here, positive here. So if you are having negative here and then positive here, so it means that these two diodes, D3 and D4. So in this case, D3 and D4, so they are closed switch or short circuited. D1 and D2, they are open switch or open circuited. So they are open circuited, short circuit, and then short circuit. And then you will end up whatever the input. So if it is negative, then you will end up VIT will be the negative of the message signal. So basically VIT is you can represent VIT in this format, that is the product of the periodic pulse and the modulating signal. So if we want to draw the graph of the periodic pulse, so PT, so the graph should look like this one. So you can see the amplitude is +1 and -1, and this is the base, this is the base of the amplitude of the this is the base of the curve. So from -T/4 to T/4, so the period is 1, and then so here, so this is -Tc/2, so this is -3Tc/4, and then this is -Tc, and this is similarly here. So this is the periodic pulse that is going to be multiplied with mt. So it means that if plus 1 is multiplied with mt, you will end up with plus m. So if minus 1 is going to be multiplied with mt, so you will end up with the minus mt. So this pt looks logical, that we can write vit is the product of mt and pt. So what is pt? So you can represent pt using the Fourier series. So what is the Fourier series of pt? So that is equals to a naught by 2 plus summation from starting from n is equals to 1 to infinity an cos n omega ct plus bn sin n omega ct. So these are the coefficients a naught, an and bn. So we can calculate these coefficients separately. A naught, we know the formula of a naught is equals to 1 over tc by 2, and then starting from minus tc by 2 to tc by 2 and pt. So this can be again written like this format: 2 by tc and minus tc by 4 to 3 tc by 4. So this is logical again because it sum up to one period. So sum up to one period, so pt and then dt. So you can open this into two different periods, like from minus tc by 4 to tc by 4, and then from minus tc by 4 to 3 tc by 4. So over there from minus tc by 4 to tc by 4, so this is positive. From minus tc by 4 to tc by 4, this is positive. And then from minus tc by 4 to 3 tc by 4, so you can see from minus tc by 4 to 3 tc by 4, so this one is negative. So that one is negative. So we know the integral of constant will be t, and then if you insert the limit minus t by 4 and then minus t by 4, so t by 4 minus t by 4, so that will be tc by 2. So this is the first limit. Like if you insert tc by 2 and then minus tc by 4, tc by 4, that is equals to tc by 4 plus tc by 4, so that is equals to tc by 2. So that is this one. Now similarly, if you insert this one, so the integral of minus constant will be equals to minus t. So if you insert the limits here minus t, so minus 3 tc by 4 and then plus 3 tc by 4, the answer will be equals to 3 tc by 4 minus tc by 4, like 3 tc by 4, this is minus, and then plus tc by 4, this is plus, so 2 tc by 4, which is equals to 2 to the 4, and then you have minus 3 tc by minus tc by 2. So you have that one. So tc by 2 minus tc by 2, the answer is 0. The second component is an. So we can calculate an. The formula of an is 2 by tc and integral of pt cos n omega ct from minus tc by 4 to tc by 4, from tc by 4 to 3 tc by 4, and then you have again 1 cos n omega ct dt. So if you take the integral, we know that this is a constant, the value of this one is 1. So the integral of cos n omega ct is sin n omega ct divided by the extra component n omega c, and these are the limits minus tc by 4 to tc by 4, minus again the integral of cos n omega ct is sin n omega ct, and this is the additional parameter n omega c, and these are the limit tc by 4 tc by 4. We know that omega c is equals to 2 pi fc, and what is fc? So fc is equals to 1 over tc. So we can insert 2 pi by tc, or t can rearrange, so omega c and tc is equals to 2 pi. Similarly here, so omega c is here, omega c is here, so these are the common, so we can take them out. So and then we know that omega c tc is equals to 2 pi. Okay, so that is why we replace them with this one. So we have 2 by 2 pi n, and then sin n omega c, and then insert the limit t. Upper limit is tc by 4, so tc by 4 minus lower limit sin lower limit is minus tc by 4 minus n omega c tc by 4 and then this one minus sine 3, because you are inserting the upper limit 3n omega tc by 4, and then plus, because if this is minus, so that's why minus and then minus, it becomes plus. So plus sine, again lower limit, the lower limit is tc by 4 n omega c tc by 4. So these are constants, so you know sine n omega tc by 4, so minus and minus, plus sine n omega tc by 4 sine n omega c tc by 4. So 1 plus 1 plus 1, it becomes 3. So 3 sine, and we know that omega c tc is equals to 2 pi. So we can replace 2 pi here. So if you replace 2 pi, so then 2 pi by 4, 2 pi by 4 is equals to pi by 2. So that is pi by, so this one is pi by 2. Okay, so that is the 3 sine n pi by 2, and then minus, so that one sine 3n pi by 2. So sine 3n pi by 2. So this is the result of an. The second coefficient is bn. So the answer of bn is, we can straightforward say that bn is equal to 0. Why? Because it is even signal and it is symmetrical about the y-axis. So no need to calculate the value of b. We can directly say that b is equals to 0. So we can insert all these values in the pt. So what is pt? So pt is that one. So we can insert all the value here in pt. So using the pt, so pt will be equals to a naught is 0, so that is why you are right 0. So the other one is 1 over n pi 3 sine n pi by 2 minus sine 3 n pi by 2, and then extra term, so which is cos omega ct. So you are writing, now this one is cos omega ct. So you are writing cos omega ct. And then now keep inserting the values of n. So for n is equals to 1. So if you insert n is equals to 1 here, so n is equals to 1 means sine 3 pi by, so if n is 1, sine 3 pi by 2. So sine 3 pi by 2 is nothing but it is equals to minus 1. And here if it is n is 1, so sine pi by 2 is 1. So you have minus 1 and 1. So if you insert n is equals to 2, so n is equals to 2 means 2 cancel and sine pi is nothing, it is equals to 0. So if you here insert 2, so 2 cancel, sine 3 pi is again 0. So if n is equals to 3, so if n is equals to 3, so 3 3s are 9. So sine 3 pi, because 3 multiplied by 3, 9 pi by 2. So sine 9 pi by 2 is nothing, that is you can write sine 4 pi plus pi by 2. So sine 4 pi you know equals to 0. So the remaining, so sine 4 pi plus pi by 2 can be equals to sine pi by 2. And we know sine pi by 2 is equals to plus 1. And then sine, if you insert here sine 3 pi by 2, so that is equals to, so sine 3 pi by 2 is equals to 1. So you can just use these values here. So pt is equals to 4 by pi cos omega ct. So if you inserting all these values in this equation, so that is equals to 4 by pi cos omega ct minus 4 by 3 pi cos 3 omega ct. We are getting odd harmonics, like you can see 3 and then here it is 1. So we are getting odd harmonics. So we use this pt in the main equation. So we are inserting this pt in this mt. So that is vit is equals to mt multiplied by pt. So mt multiplied by that equation. So we are keep writing these values and then some additional terms. So it looks at the input of the band pass filter. So from this equation you can see that the input of the band pass filter is the products, like only the product appear, the product of mt and pt. Only the product appear at the input of the band pass filter. So that is why, so there is a no mt, no carrier. So you can say that it is a double balanced modulator. So ring modulator is a double balanced modulator because it is suppressing the message as well as the carrier. Like no carrier appears at the input of the band pass filter, no message appears at the input of the band pass filter. So that is why it is known as a double balanced modulator. So if you pass the VIT, from the band pass filter whose cutoff frequency is fc and whose bandwidth is 2fm, then you can see that this message has a frequency. So this message has a frequency fc. So this message has frequency 3fc and this message has frequency 5fc. Okay, so if you multiply with mt, so then fc plus minus fm, so 3fc plus minus fm, so 5fc plus minus fm. So it will not allow to pass these. It will only allow to pass this signal like 4 by pi mt and then cos omega ct. So you can see this signal looks like a double sidebands whose frequency is fc plus minus fm. Double sideband and suppressed carrier. Like if you want to write this in the spectrum of that signal, so if you want to write the spectrum of this signal, so the spectrum is something like that. Like the frequency of this is fc and then fc minus fm, fc plus fm, and the spectrum of this signal is centered at 3c. The spectrum of this signal is centered at 5c. But our band pass filter has a frequency which is centered around fc, so that is why this will pass and these two will block. It cannot pass through the message signal, through the band pass filter. So that is why we are ended up with that output. So that is the double sideband with the suppressed carrier. If we wanna write in the time domain, so that this is our message signal. So this is our PT, like plus and then minus. So if you multiply them together, so you will end up with the modulator signal. So that is your message signal and this is your PT. So it means that you are ending up with this type of waveform. So you can see that you are ending up. So you are ending up with that type of modulated signal. So that's all for today lecture. I hope that you understand the ring modulator circuit diagram and its analysis very well. But if you still have any question, you are most welcome. You can write your question in the comment box. Thank you for watching the video.